Hello everyone, welcome to our channel. So guys, today we'll solve question related to crystallographic direction and the plane. So you will understand like how we can calculate the direction and the plane using the basic concept. So if the question is slightly tricky, like it can happen like they will give some planes and the direction which will be slightly confusing. Okay, so you can get the solution right here. So hello guys, let us see again the questions related to directions and the planes in the unit cell. Okay, so the question is, using proper crystallographic notation, identify the crystallographic direction A and the crystallographic plane B depicted in the figures below. The crystallographic direction and plane are shown in the cubic unit cell. Okay, so if you have seen my previous video, then you can think like how to proceed. Okay, but no problem, I am again telling you for the option A. For the direction, you always remember that you have to subtract the coordinate of the head of the arrow to the base of the arrow. Base, or you can say like tail, right? Head and tail. Okay, so you see this is the arrow, right? And we have the head over here. So what is the coordinate of this head? So you can see that in the x direction I need to move 1. So 1 will be sure, right? Then next we need to move in the y direction by 0.25 times, that means 1 by 4. And the z direction, do we need to move? No, so it is 0. So basically 1, and it will be 1, then 1 by 4, then 0, right? So minus tail. So what is the coordinate of this tail? So you can see that to reach over here I need to move in the x direction. Do we need to move? No, right? So x, it will be like 0. And do we need to move in y? Yes, we need to move in y by how much? This 0.5 times, that means half. Then in the z we need to move to the top. So to cover to the top we need to move, so complete z1. So it will be 0, half, 1, right? So it will be 0, half, 1. So now subtract it, very easy. So 1 minus 0, 1. 1 by 4 minus half, right? So 1 by 4 minus half, so it will be minus 1 by 4, right? Then 0 minus 1, so it will be minus 1. Okay, so we have got one fraction over here in the middle, so we need to convert it into integer. So what we'll do, we will multiply with 4. So it will be 4 minus 1 minus 4. So if you want to write in Miller unit system, then this will be 4, then 1 bar, then 4 bar. Okay, simple. Now let us move to option question B. So we have been given a plane, right? So you can see this is kind of triangular plane, and it is cutting somewhere in the x direction, in the z, in the y also it is cutting. Is it cutting the z1 also? I think yes, it is cutting some. But since the plane is at the origin, so we need to move the origin. So where can we move this origin? So what will be the most suitable place where we can move this one? Okay, so guys, we can easily move this one to the right direction. Okay, so next origin will be here, x, y and z. Okay, so once we have moved this one, so in the x, what is the intercept? So in the, for the case of plane, we need to first find the intercept like x, y and z. So in the x we have one intercept, in the y we have negative 1x intercept, in the z we have half intercept, right? So now let us do the reciprocal. So it will be 1 minus 1 then 2. So Miller indices will be simply, since these are already integer, right? So 1 minus 1 2. So Miller one, it will be 1 then 1 bar then 2. Okay, simple.